Next, second process is a cooling process. But you see, if I say cooling, I'm not talking about evaporative cooling. I'm talking about the cooling with the, say, cooling coil. Means by using the DX system. You see, cooling is usually accomplished with the chill water or refrigerant. So in this case, I'm not talking about evaporative cooling. For evaporative cooling, we have a separate process. Okay, evaporative cooling means that we'll talk about only sensible. But here, if I talk about the cooling with the chill water or refrigerant, means in that case, you'll find sensible plus latent, because the moisture also condense on the cooling coil, na? As we discussed at the time of vapor compression cycle. So it's not sensible cooling, it's a sensible plus partly latent cooling. So how exactly? We'll discuss. This is interesting and important. So, you know, because of this condensation, drain pan or rainwater from the units. How exactly from the unit, that we'll discuss in chapter 5. Now, so just focus on the heating, the cooling process. So next in cooling process, you see, example I'm considering, you see 80-degree dry bulb and 67-degree Fahrenheit wet bulb. Most commonly, we are considering this example as a standard. These are standard conditions, just assume that. And this dry bulb and wet bulb, I'm interested to reduce to 55 and 55.4 dry bulb wet bulb. This is my requirement. Okay, from this to this is my requirement. So see, higher temperature, lower temperature, na? So cooling is required. One point you can understand. Just example. Now, just will inspect point 1 and this is point 2. Okay, so what are the conditions at point 1? But before this, you know how to achieve the cooling with the cooling coil, either with the DX system or with the chill water system. The more about this coil we'll discuss in detail in chapter 5, don't worry. But we already discussed vapor compression cycle, so you can relate. In vapor compression cycle, refrigerant is flowing. In chill water system, chill water is flowing. That is the difference. Rest of the thing is same. You will, in both the cases, you'll find the cooling coil and you'll find the sensible latent condensation, etc. So the first point, let me verify this RH. Acha, before this, you see, with this 80 as dry bulb and 67 as wet bulb, you know, you can find out the point on the psychrometric chart, na? What we discussed in the previous session, right? So how I'm getting this point 1 and point 2, I think everyone aware of this. Any confusion is getting this point 1 and point 2? Okay, let me quickly show you. You see, point 1 condition is what? This condition, 80-degree dry bulb and 67-degree wet bulb. So you can see 80-degree dry bulb, this line is going up. And you see this inclined line is a wet bulb, na? So you see 60 and 70. So in between, I can consider, say, this is 60, this is 65. So we require 67. So this is the point. So with this point, if I move in this same inclination and 80-degree Fahrenheit dry bulb, so this is a point, right? No confusion, getting the point? Using the psychrometric chart, everyone aware of this. And the same is applicable for all the process. How we are getting the point means by using the two properties of air, you know. Now, the second point condition, you see, 55 and 54.5. 55 is what? Dry bulb. You see, 50 and 60. In between, I can consider 55. So if I go up straight, and you see this is 50 and this is 60. So in between, I can consider round off to say 55. Na? So this is a point. Dry bulb and wet bulb. So point number 2. Now we'll try to find out the different conditions. So first of all, can you relate? It's a cooling process. You see, point 1 to point 2.
Yes, temperature is decreasing.
Right, decreasing temperature, na, from 80-degree Fahrenheit to what, 55. But apart from this, this is not a straight line. If a straight line means we can consider only sensible, but it is going up to this point straight. After this, going down. It means if you check this humidity ratio, change in humidity ratio means change in the moisture, decreasing the moisture. You see, at this point, the moisture level is more. This point, the moisture level will be less, na? Because you see, this is 60 and this is 80. So decreasing the moisture means the condensation process means latent also involved. Or else further, you see, if I just draw the line, this I can consider latent and this is sensible. This is latent cooling, this is sensible cooling. Latent, I'm considering vertically down because you see, decrease in the moisture, na? This W value. And sensible, I'm taking this point. Suppose 1 to A, then 2. So 1 to A is latent, A to 2 is sensible.
Oh, can I explain this point again?
You see, 1 to A is latent. Why latent? Because decrease in the moisture means condensation process. And A to 2 is what? Sensible, because it's going straight, na? But in the process, going straight up to this point, then it is dropping. Just to simplify, I did like this. Okay, so this drop is a latent and state is a sensible. So it means sensible as well as latent. Both the processes happening in this. So now let me check this point 1, RH, relative humidity. RH1. 1 means all this point related to this one. So you see RH1, can we consider say 50? You see, this is 40, this is 60. So in between, this is 50 now. So RH1 round off to exactly is 51.1. You can check in the psychometric software. Then RH2, you see, this is very close to this saturated line. This line is a saturated line where RH is 100%, right? This is a saturated line, right? 80, you see, 60, 80, then this line is 100, the saturation curve. But you'll not get exactly 100. You'll get say 97%. So remember why we are not getting this 100% saturated air. The reason is, for example, if I draw this cooling coil and air is flowing from this left direction to right. So what will happen? Air will pass through this coil. No? And in actual practice, you'll find the coil with a bunch of fins. If you don't know fins, don't worry. I'll show you the image at the time of chapter 5. So what do you think? Suppose if I supply one, say 100 CFM, cubic feet per minute, the flow rate of air. So what do you think? This 100 CFM completely touches to the coil?
No.
No, sir.
No. So the air which touched to the coil is called contact air. And the air which not touched to the coil or fins is called bypass air. Okay. So in actual practice, you cannot expect 100% saturation. That's the reason 90%, even though this point is on this line. So 97 means 97 because of the contact air. Remaining 3% is because of bypass, and that we can call as a bypass factor. So in this case, 97% is a contact factor, and or I can say 0.97 is a contact factor, and 0.03 is a bypass factor. So what is contact and bypass factor? We have a separate topic. In detail, we'll discuss with the equation. At this level, why I'm not getting 100? Just that's the reason I explained this. So 97% RH. This is a RH condition. It means, you see, with the cooling process, RH increases. So this is not the desirable condition. No? And at this level, just remember, I'm talking about only cooling. I'm not talking about the dehumidification. So because of cooling, because of this latent heat, the moisture decreases, and moisture decreases as the humidity decreases. What will happen to the relative humidity?
Relative humidity increases.
You see, in this case, okay, let me write all this point, then you'll get the clear picture. Now, the second point is a dew point temperature. Suppose DPT1, sorry, my mistake, DPT1, dew point temperature. You know, dew point temperature you'll find on the same scale no? as of this RH. So DPT1 60.4, and this is degree Fahrenheit, and dew point temperature 2 is 54.2 degree Fahrenheit. So what happened to this dew point temperature? Decreases. Okay, and this is a dew point temperature of what? Air. We're talking about this condition of air, no? And the delta T we can consider as 6.2, the difference of this. Next, humidity ratio, WW. W1 I'm considering 78.2. You see, this point if I go straight less than 80, no? This 80 grains per pound of dry air, this is a point. And this, when you draw, you'll get less than 80. So exactly when you check the psychometric software or psychometric chart, you'll get 78.2 what? Grains per pound. And W2 is what? You see, this line. So above 60, below 80. So when you check, I got 62.4 grains per pound of dry air. Now, so you see, this humidity ratio decreases now because of extraction of moisture, because of condensation, right, on the coil. Next, what about the enthalpy? H1, you see H1 at this point, this is H1 and this is H2. So H1 you see above 30, exactly is 32 BTU per pound. H2 is what? 21.6 BTU per pound, and delta H is 10.4 BTU per pound. Now the conclusion is, if you extract 10.4 BTU per pound, the temperature can decrease from 80 to 55 dry bulb, and the wet bulb. We'll verify this wet bulb also. You see wet bulb, this blue color line is wet bulb. See 60, 70, so 65 or 67, this one. This is a point. And this point wet bulb is what? 50, 60 means I can consider 55.
50,
We're
54.
getting so with this matching. You see this condition we require to achieve. So with this condition means if you want to maintain, if you want to this dry bulb and wet bulb, if you want to change to this 55 and 54.5, this much of heat you need to extract. Okay. And this is what? This is not just sensible. This is sensible plus latent. This enthalpy is what? Is the summation of the dry air and the moisture. No? In the previous case, that was only sensible because that is heating in a straight line. But in this case, straight and it is going down. So it's a sensible plus latent. Latent, no doubt, very less compared to sensible, but it's both. So 10.4 BTU per pound. If you extract, one can achieve this condition. So this is a cooling process. So what happened in the cooling process? In the cooling process, remember the cooling process, RH increases and the humidity ratio decreases. And what else? We need to extract the heat. In the previous heating, we add the heat. Here we are extracting the heat. Okay. So both in BTU per hour, but one is adding, one is extracting. Yes.
So at point 2, we have humidity ratio 62.4. I mean, there is a condensation in the evaporative coil, so that humidity ratio is decreases. At the same time, I can see that relative humidity is also increases. Still, you have decreases the specific humidity ratio.
But that is an important point. What we discussed in the previous.
Okay. Yeah, it's a reverse case. I mean, temperature decreases.
No. You see, that depends on the temperature. This RH level, you see here, you are asking means this W2 decreases, but the RH increases, right?
Yes.
But you see, based on what? Based on the dry bulb. Dry bulb temperature. So you see, if you talk about this RH means 0.1, the temperature is more. And at 0.2, the temperature is less. Less temperature means less holding capacity.
Yes.
Okay.
Less holding capacity, that means relative humidity increases.
Yes, means it can extract more moisture, so the capacity increases. So I think you're getting a point.
Yes, I'm getting it.
This is a very important point to understand. So with this, you'll get the clear idea between the humidity ratio and relative humidity. Adding or removing the moisture, it not mean that the RH also means increase or decrease in the same way. If you maintain the same temperature, yes. But at different temperature, the RH level will be different. Okay, it's not mean that adding the moisture must increase RH level. No, that depends on the temperature. So that depends on temperature. As the temperature increases, then the holding capacity of moisture by the air increases. Okay.
Also, we can, I think, relate about the dew point temperature, because temperature is decreases, dew point temperature also decreases. At point 2, we have dP2 54.2. So temperature decreases, I mean the relative humidity increases.
Yes. So you see, for that reason only we are talking about this process. So you need to understand the relation between these parameters. So at the time of designing, you can take the decision as per the application requirement. What exactly the requirement, according to that, we can control that particular parameter to get the required result.